welcome to the third part of this IGCSE chemistry warm-up video for the second paper in 2018. I'm going to skip through to the question we got halfway through on the production of ethanol. Okay, so here we go. In this question we're asked to evaluate which production technique is used by each country, and there's lots and lots of factors which we are told here. Country A is large, so it's got a large land mass, large area. The climate allows crops to grow easily, and it doesn't have any oil reserves. So country A is most likely to pick fermentation as a method of producing ethanol. I would certainly be talking about here that it has the climate suitable to grow sugar. You might also want to add something about it's got a large amount of land available to grow sugar, or the fact that it's got no oil reserves, so it's not going to be able to easily get hold of any ethene, which is produced by cracking crude oil. Country B is densely populated, so it's not going to necessarily have a large amount of farmland, but it's got its own oil reserves. So that's definitely going to be the hydration technique. So it's got oil reserves used to make ethene. Now, questions recently have often asked students to evaluate the pros and cons of the two different ethanol production techniques, and one of the phrases they've liked seeing in recent years is talking about renewable resources. So sugar is a renewable resource because it's easily replaced. You can just grow more sugar. Whereas crude oil is a non-renewable resource because after you've used the crude oil, it takes millions and millions of years for it to form again. So that is something which is worth looking out for. The final part of this question actually looks at the dehydration of ethanol, and here they've talked about using concentrated sulfuric acid, which is a dehydrating agent. On the syllabus they don't talk about that as a dehydrating agent in this reaction. Now the answer which you're looking for is water, but the syllabus talks about using aluminium oxide as a dehydrating agent, so Al2O3, and that's really why I included this question, because I wanted to point that out, but conc sulfuric acid would also work. So this question concerns atomic structure and then moves on to looking at halogen displacement. And you should be spotting that atomic number is the same whatever the isotope is, and so the number of protons here 35, and here 35 as well, and the number of neutrons of a substance is the same as the protons taken away from the mass number. So the mass number is protons plus neutrons. So here we've got number of neutrons 44. 44 plus 35 gives 79, and here we've got 46 plus 35 gives 81. I might have expected here to see a question on define the term isotope, and the answer to that is the same number of protons but a different number of neutrons. And in the past I found students get confused between the term isotope and the term isomer. And a student who I remember teaching a few years ago came up with a way of remembering that, and he said, well, isotope has got a P in it, and that tells you you've got the same number of protons. Isomer has an M in it, which tells you that those are structures that have the same molecular formula but a different structural formula. So that helped him decide between isomer and here with isotope, the same number of protons. Now, the relative atomic mass of a substance is the average of the mass numbers of each isotope, taking into account the natural abundance of those isotopes. And you can see here that the average is 80, which is slap bang in the middle of those two mass numbers, which tells you that you must have an equal amount of those mass numbers. So 50% of each. So they have equal abundance. And now we move on to the displacement reaction, and you can see here that we've got bromine being made. So if I was building an equation as I'm going on, I'd probably put Br2 on the right hand side, and here you need to know obviously it's a diatomic element, and you're making it by taking some chlorine gas and you're mixing it with a solution that contains bromide ions. So here we want Cl2, and we're going to take bromide ions, and at this point you might then be slightly stuck. You think, what am I going to make? Well, you can see over on the left hand side we have got a negative charge, which suggests we need a negative charge over here. We've also done nothing with the chlorine, so it seems sensible that we might make Cl over here, which has a negative charge. We make chloride. Now on the right we have two bromines, on the left we only have one, so let's try and balance that by putting a 2 here, and here we have two chlorines and only one over here, so I'll put a 2 there, and that balances both the charges and the number of each atom in there. Now, iodine couldn't be used instead of chlorine in this process because iodine is less reactive than bromine. Therefore, iodine is not able to displace bromide from a solution. And we'll go over the page. Right, so this is a good question. I'm just going to flick over my page. I'm still working off a paper copy here. So name a compound containing iodide ions which would be suitable for this reaction, and it's really important here that you name the compound. You don't write any symbols down, so I'm going to choose sodium iodide. You might be thinking, well, how on earth do I know which one to choose? And you could have absolutely loads: sodium iodide, potassium iodide, lithium iodide. All this is asking you for is to name a soluble iodide. So something like lead iodide would not get you the points, because lead iodide is an insoluble salt. It's a beautiful yellow compound, which many of you will have made in precipitation reactions, but that certainly wouldn't get you the points. Now, one change you might see as we're doing this reaction is that you're producing iodine, which is in solution. And iodine in solution has a brown colour. I remember having a motorbike accident years ago, many years ago, and I had to put iodine on the cuts on my arms, which I acquired, which was incredible, which stung incredibly, but obviously was obviously excellent in terms of an antiseptic. Okay, so why is bromine said to be reduced in this reaction? And for this, I'd refer to oil rig, or as I prefer, Leo Ger. So oil rig, oxidation is loss, reduction is gain. Leo Ger, lose electrons, oxidation, gain electrons, reduction. So why is bromine said to be reduced? Because it has gained, each atom there has gained an electron. And what happens down here? Well, we've got the iodide ions being oxidized. They're being oxidized because they lose electrons. So we obviously need two of them, because you've got two on the right hand side here, and you've got a charge of 2 negative. So on the right we need 2 negative electrons. Each iodine will kick out 2 electrons there. In this question, we're asked to look at the chemistry of hydrogen chloride. Now, when you've got a molecule of hydrogen chloride, hydrogen and chlorine are both non-metals, so it must be a covalent bond. I'm not quite sure why we've got a squiggle there. So there's the hydrogen, and here is my chlorine. Chlorine's in group 7, so it only needed to gain 1 electron, so there's the cross and there's the dot, and here's my other electrons there from the chlorine. So you can see we've got 7 electrons originally from the chlorine, and there's my 1 electron which originally came from the hydrogen. Now, when you dissolve hydrogen chloride in water, this molecule breaks up. It dissociates, and you form H+ ions, which cause acidity. So the colour of litmus paper, when you put it in that solution, is red. Okay, because you've got H+ ions present, so you've got an acid. Now, when you put hydrogen chloride in another solvent, in another liquid, in this case methylbenzene, which is also called toluene, you don't get dissociation. The hydrogen chloride stays together, which means you don't have any hydrogen ions present. At this point, emphasising that it's H+ on my original script. Okay, so because there are no H+ ions present, the litmus paper stays the same colour, so it stays blue, and it does that because there's no H+. Okay, it's not an acid. It's not fair to say it's an alkali, it's just fair to say that it's not an acid. And there ends that part.